Just a quick disclaimer, I am going to be making use of this circuit here because I don't want to keep rebuilding it. Let me move that one out of the way. And for this video, the only thing I'm going to be focusing on is the actual LCD and the I2C adapter. So I won't be using the LEDs, but I don't want to unplug everything and have to plug everything back in. So I'm just going to leave it as it is. But just again, I'm going to be using the I2C adapter here at the top and the LCD. I'm just going to put some basic text on the screen and that's it. What am I going to do this time? I'm going to be using the Raspberry Pi, so parts and justification. I'm going to have a block diagram and I'm going to have Fritzing diagram, might as well. Those are the only things I'm going to have. So my parts for this one, I'm going to have the I2C adapter 88P TER. I'm going to have the LCD screen. Oh, the one thing I left off was the pin connection. So pin connections down here. Okay, what's going to be, let's make this a heading 1 just so it stands out. I2C adapter, what is that going to be used for? So the I2C adapter, well, I2C is a communication protocol, and the I2C adapter allows me to not use all 12 or 16 pins on my LCD screen to connect to my Raspberry Pi, because my Raspberry Pi only has about 28, I believe, programmable pins. I don't want to waste those pins using 16 of them for the LCD. So the I2C adapter allows me to just use 4 pins. Well, technically 2, because we have the 5 volts going in and we're also going to have the ground. So we only need serial data and serial clock, I believe. So I2C adapter, the whole purpose is to reduce the amount of pins and make it a much more efficient way to communicate. And the LCD is just so I can write stuff to the screen. Okay, I'm not going to be doing all the justification stuff here. You guys can write that in yourselves. Block diagram, I might as well do this one. So if I go to my folder, which is here, I'm going to right click, new PowerPoint, Microsoft PowerPoint. Here we go. This is going to be block diagram. It's always good to have a block diagram for your circuits. It's not always needed, but it's a good idea to have. I'm going to go insert. I'm going to go text box here. And now for this one, I actually don't need any input. So I'm going to do processing and I'm going to do output straight away. So click on that, copy and paste. I'm going to do output on this side. And for the processing, I'm going to go to insert. I'm going to go to where shapes here. I'm going to go rounded rectangle and I'm just going to say Raspberry Pi Pico. Now, the reason I keep doing this again and again and again, I want people to get really good at doing this really quick at this process so that when you're in the exam, for example, for Unit 6, BTech Level 3 Engineering, it's just second nature to you at that point. And for output, I'm going to put LCD. Now, I'm not going to put the I2C adapter in here. There's no need for me to have it in here. So this is it. This is all I need. I need to go back to insert. I need to go back to shapes. And I like using the elbow arrow because it moves along with my thing. The reason I use it, so if I click on this and I move it, let's make this thicker actually. Shape outline, increase the weight to about 4.5. Wherever I move this to, it moves with it. So if I'm creating a diagram and I have to move something up or down, this will move with it. So that's it, LCD done. I'm now gonna screenshot this. So this is all I need to grab. I'm gonna go back to my Word document here, block diagram. I'm gonna paste that there, make that heading 1, close this and shrink this. So all I've done is I've pasted my screenshot in here. And the way I did that, I pressed Control, so CTRL plus a V for Victor. Once you screenshot it, you don't have to copy it. It copies itself straight away. Let me remove that. And for my Fritzing diagram, nice and easy one. So let me go to Fritzing, I believe that's here. Click on that. Now the components I need for this are actually in my folder. I will try to share on the website and in my video description all the files you'll need for this. It might be easy when I have the website up because YouTube and sharing stuff on YouTube is not going to be quite easy. So what do I need? I need LCD. So I know I already have it in my folder. So I'm going to move this over. I'm going to go over to where it says parts and that hamburger menu. I'm going to click on that. I'm going to go to import and then I'm going to browse to the folder where my files are. So if I go to desktop and I go down to Raspberry Pi Pico how to, simply browse to the folder where you've saved your stuff. I've saved mine in LCD. And these are the 2 components I need. So I need the LCD display first. Then I'm going to import the other thing. Go back to the hamburger menu. Go to import. It's moved again. So back to desktop. And I'm going to grab my I2C adapter. I'm going to drag both of these on screen. That one and that one. I need to flip this around actually so I can have this lined up with this. Reason being, I want to be lazy. That's it. Drag this onto my breadboard. Actually, let's put it on this. Yeah, that should be fine. Drag this over as well. And I'm going to click on this and I need to rotate 180. So go down to rotate, click on the arrow and go rotate 180. Reason being, I want this to line up as perfectly as possible. I don't want to do any more connections. So on your breadboard, this is how I've actually plugged it in on my breadboard. Once they're lined up, that's it. You don't need to do anything else. I need to now connect these pins to the right pins. So I'm going to go back to my folder and I'm going to open my pin layout. Let me minimize this. Let's make that as big as possible so I can keep jumping back and forth. Oh, this is the wrong way actually. So let's do that. All right, I want it to go to ground. So the first one, I believe, is ground. So I'm going to connect that one to ground, which is, let's connect pin 3. So if I zoom in, pin 3 here, down to ground. And let's do, I think it's one of these ones here, to positive. Let's do something like that. Right, so ground is going to be down here. But let's make this look nice. Let's drag this over like so. Yeah, that looks good. VCC is going to be 5 volts, so that needs to come from the very top. But let's drag this out as well so it looks neat. That's fine. SDA. What pin is SDA? But before I even do that, let's double check that pin 3 and pin 40 are correct. Go back to my diagram. Yeah, VBus or VSys both give 5 volts. I think one of them is more stable than the other one. I don't remember which one it is, but both of them should give roughly 5 volts. Pin 39 or pin 40 is perfectly okay. And I've also got my ground on pin 3, so that's okay as well. Now it says I need to get SDA. So SDA, let's see which pins actually have SDA. Let me rotate this a few more times. SDA, there we go, that pin there. And that's pin 6, but GPIO4 or GP4. So pin 6, but GP4. Come back here, come all the way down to pin 6. So that's going to be 1, 2, 3, 4, 5, 6. I believe it's that one. And I can drag this out about here. And I can drag this down somewhere like so, just so it looks nice and neat. And then for pin 7, let me just double check. So that's 1, 2, 3, 4, 5, 6. Yeah, and pin 7 goes to SCL. Let me double check that. SCL, that's that one there. It's pin 7, but GP5 or GPIO5. So I go back to my diagram. I draw this one down to pin 7, that one there. And let me make this look good. Let's bring it to there. Let's bring that one to about there. There we go. Perfect. That's it. That's my entire circuit finished. This is how you connect your LCD. Now I can move it closer, but I think it's okay here. I'm going to save this first. Make sure you save it. I'm going to screenshot it as well. And to screenshot, you go to start and you could type SNIP. Snipping tool will come up and you can click on new and you can draw over the area you want to screenshot. That's one method to screenshot, and that automatically copies it and allows you to save it. I prefer the other method. I press Windows flag, Shift and S. So press and hold Windows flag on your keyboard. Press and hold Shift and then tap S on your keyboard. It comes up with this option here and you just drag over the area you want like so. That's now automatically being copied. So I'm going to go back to my Word document now, which is here. And Fritzing circuit diagram, I'm going to paste it. So you can right click and you can go to paste, or I like shortcuts again. I do Control and V for Victor. So CTRL and V. That's, oh, 1 second. That's my circuit diagram pasted there. Now pin connections, simply describe your pin connections. Let's make this a heading. Pin connections. All right. So how do we do this now? Raspberry Pi. So let me just say Pi Pico, ground to GND on I2C ADAPTER. That's fine. Then the next one is going to be Pi Pico. I think that was VCC. So pin 40, whatever that is. Pin 40 was VBus actually. So Pi Pico VBus to VCC on I2C ADAPTER. Ground is actually, Pi Pico ground is actually pin 3. So let me put this in pin 3. And VBus, I put that one on pin 40, didn't I? So let's put pin 40 in here. This way, it doesn't matter who's reading it. It's very, very straightforward what needs to be connected. So Pi Pico ground pin 3 to GND on I2C adapter. And if I go back to my diagram here, this actually says GND. It says ground. And then from there, Pi Pico VBus pin 40 to VCC on I2C adapter. Then Pi Pico SDA. So that's going to be pin 6 again, but GPIO GP, what was that one again? 4 goes to SDA on, what to say, I2C ADAPTER, and I can copy this because I'm only changing a few values for the next one. Copy it, and at the bottom I paste. This one is SCL, I believe, serial clock. That's pin 7, and it goes to GP5. And this needs to be SCL as well. SCL on the I2C adapter. And I've described my pin connections. Now, in the exam for Unit 6 BTech Level 3 Engineering, some people, you might want to do this in a table. It really doesn't matter. Once you have the pin connections somewhere explained in detail, you're fine. I'm going to put LCD here just so that in the exam, you're going to have more than one component. This is my first component. This is how I've connected it. Let's just say I had a buzzer as well. Buzzer. Then I would describe the pin connections for buzzer. And let's say I had LEDs. I would describe the pin connections for LEDs under that as well. So Raspberry Pi to resistor to LED to ground. Describe every single pin connection that goes to the Raspberry Pi. And that's it. Done. I'm going to save this, make sure it's saved. I'm going to close this. I'm back on my circuit here, and again I'm going to leave everything plugged in just because I wanted to use this stuff later on. So same thing applies here. This is my I2C adapter. I've just flipped it round so it's connected to the Raspberry Pi LCD, and I'm going to connect it to the Raspberry Pi now in that direction. First things first, let me grab, I think ground was first. I like to use a black wire or a dark wire for ground. So ground is going to be that first one. So I'm going to go ground here. Now this might not be pretty like the others, but that's fine. Down to ground here because I've connected. My ground pin goes down and it goes all the way across because I've connected that bridge there as well. So I know that that should be ground. I'm going to do positive next, VCC. That one goes to the top because I've done more or less the same thing. I've connected my VCC or my VBus to the very top one, and I've linked it at the top here as well. So I'm going to grab this, connect it there, and that one goes to the very top. The next one is going to be, I think, SDA. Let's double check. Yeah, SDA, so serial data. All right, here we go. Let's use a yellow one actually and a green one. So SDA first, serial data, connect it to that one there. Bear with me, guys. My eyes are very bad. And do pin 6, I believe. So that's going to be that one there. So again, SDA goes over to pin 6, but pin 6 is GPIO 4. Put that down, and I'm going to use green for the other one. This is going to be pin 7, so connect it there. Oh, that one's a bit tricky. There we go. And this is going to go over to pin 7. Now I've finished connecting my devices. Now I need to get onto my PC and program it. So again, let me turn this around actually. GND, which is ground, goes to the ground pin, so pin 3. VCC can go to pin 39 or pin 40 because they both give 5 volts. One is just more stable than the other, but I don't remember which one. SDA is the serial data that goes to pin 6, which is GPIO 4 of the Raspberry Pi. SCL, serial clock, goes to pin 7, which is GPIO 5 on the Raspberry Pi Pico. So that's it. I'm going to now start programming this. Before we go any further, we're going to need to put some files on the Raspberry Pi. And those files you can grab from this website called Tom's Hardware. I'll put the link in the description. You can also grab it from another website called Microcontroller Labs. You can grab it from quite a few different websites. I've made use of these files. I'm going to put them in the description as well. So you can simply click on my link and go to my Google Drive and download the files directly. You do what you want to do. If you simply Google LCD I2C Pi Pico, you're going to find quite a few websites that actually give you the files. But let me simply show you what these files look like first. So if I go to my downloads here, this is called I2C LCD, and there's LCD API. So these are essentially, think of them as drivers for the Raspberry Pi Pico. Someone has sat down and written program to make the Raspberry Pi Pico work with the LCDs. So let me double click on that and the I2C adapter. And let me double click on this one as well. This is what they look like when you open it. You do not need to edit any single thing in here. Don't edit anything. The only thing you guys need to do is have your Raspberry Pi Pico connected, and then from there you go to File, go to File, Save As, and then you choose your Raspberry Pi Pico from the list that comes up. Or for people that know the shortcut is Control, Shift, and S, and the same option comes up. When the option comes up, click on Raspberry Pi Pico, and the name that you were told to save it as, that's exactly the name you need to save it as. Now, my first one here is, which one did I have first? I2C LCD. So when I go to save it to my Raspberry Pi, it has to be exactly the same name, I2C LCD. So when I go to Raspberry Pi Pico, put the name here. I think I already have one saved, so let me just click on that one. I2C _LCD, and the I is underscore. So I, number 2, lowercase I, number 2, lowercase c, underscore LCD dot py. That's the name you saved that one as. And the other one is going to be more or less the same thing. Control, Shift, and S to bring that thing up again. And this one is LCD API. And that one is going to be lowercase everything, lowercase l, lowercase c, lowercase d, underscore, lowercase a, lowercase p, and lowercase I. And you obviously put the .py as well to make Python, to make the thing know it's a Python file. And that's it. Once you have those two things saved, then you connect everything as you should, and then you can start doing stuff with the LCD. Now, I have a very simple program here, and there is some setup at the top. So let me quickly go over this. So this is all the stuff I've imported. Now, you don't have to import everything here, but I just make use of this stuff later on, so I have it. Now, the main thing you should probably do is get the address correct here. And again, there's another piece of code. Let me open that one as well. I2C scan. I found this on some random website. You can run this, and it's going to tell you the I2C address. Now, typically speaking, this is either 27 or 39. Those are the only two numbers I've seen pop up on the boards I have. So it can be 27 or 39. It doesn't really matter what it is. But once you go back to this program here, if it says 0x27, which is a hex value, you simply change this to 39 if it doesn't work. Or once you run that I2C scan, it's going to tell you. I ran mine earlier, and if you look at the bottom here where it says shell, it told me mine is at 27. But for some of you, it might say 39. That's the only difference. Nothing else changes. So let's import the stuff we need. So the only two things we need at the moment are from machine, well, the three things, sorry. From machine import I2C. So we're telling the thing to be able to use the I2C communication protocol. From LCD API, so that file we saved earlier, we're going to import a function from that file. Don't worry too much about it. So again, that file we created earlier, LCD underscore API, we're going to import only a function from that file. And then the other one is I2C LCD. We do the same thing there again. We import from that file another function that we want to use. We don't even need sleep or anything else, but these are the main three we need. I only added these because I know I'm going to be using them later on. The first variable here says I2C address. We simply specify the address of the I2C communication protocol. So in my case, again, it's 27. In your case, it might be 39. So if 27 doesn't work, try 39. And I have this really weird thing where 27 and 39 seem to work for some of the boards I have, but don't worry too much about that. This says total rows. This is just the rows on the actual board. So for example, here, hopefully you guys can see that clearly. We have a row at the top which is lit currently, and there's a row at the bottom which is not lit. So it has two rows. And then the next one says total columns. So this is just the individual boxes. So the columns are going to go vertically. So if you pause the video for a second and count those individual boxes, it's actually going to be 16. So I unplugged that by accident. Let me plug that back in. There we go. Yeah, that is going to be 16. And that's it. Now, there is something else that we can do, which is to maybe pull these values out as well. So I can maybe copy that, put that there, and I can maybe copy this and put that there and replace this entire thing with just SDA and replace this entire thing with just SCL. But you know what? I'm going to leave it as it is now. It works fine. So again, we have the I2C address, we have the total number of rows, and we have the total number of columns. Because remember, this is a 16 by 2 LCD screen, 16 meaning the amount of columns, the 2 coming from the amount of rows.
Now I've said I2C equals 0. I actually don't remember what this 0 stands for. This is just telling the variable name to use the I2C communication protocol or method. We say SDA. Remember, we had the SDA pin, the serial data pin, and we also had this the serial clock pin. And I connected them to pin 7 and pin 6, I believe. But pin 7 is GPIO 4. So that's what we put here. And pin 7 is GPIO 5. So that's all that this is saying. Use those pins, use that one for SDA, and use that one for SCL. Now, frequency being, I think this is 400,000. We leave that as it is. I've never touched that before. I don't know why it's 400,000. I haven't read the documentation properly, but it's 400,000. And down here, we create the LCD variable and we say I2C LCD, and we put the I2C value we had before. We put the I2C address, which we had before. We put the total number of rows. So we're essentially making up our LCD, and we're telling it the address of the LCD. We're telling it the amount of rows it has, and we're telling it the amount of columns we had. So this is the stuff that needs to be at the very top of everyone's code, essentially, right? Well, not everything in the import, but definitely these two lines at least. You can modify them. So I've modified this to be pin 4 and pin 5. You can use other pins. I've seen many people use pins 0 and pin 1, I believe, but it really doesn't matter. It's just changing the pins that you're using. So my SDA pin is pin 4 and my SCL pin is pin 5. Now, simplest program you can do is simply to write some text to the screen. And I've said LCD clear. So I clear the LCD because the way these work, they could have some text still saved to the LCD output, and what you want to do is clear everything. So wipe everything from the display so it doesn't show any previous stuff. Then I say lcd.putString. So let me put a comment in here actually. Why is my tab not working? All right, cool. Let me just move this out, and I'm going to say clear the screen, and below here I'm going to say put values, or put values to LCD, and that's it. So when I run this program now, let me zoom out a bit. I'm going to press F5 on my keyboard, and this is what should be, hopefully if I haven't messed anything up, this is what should come up on my LCD screen here. So let me hold that up. Now again, nothing else on the board is being used right now, only the LCD and the I2C adapter. I'm going to press F5. Have I messed anything up? I don't think so. There we go. Let's count 0 to 10. That's it. And keep in mind, that's only using the very, very top part of the LCD. I'm going to show you a few more tricks that you can do, but this is just the basic intro so far. So now let's get into writing to the bottom part of the screen. So again, I've written on the top row, and now I need to write on the bottom row as well. I just went back to one of those websites and I found some extra code here. As you can see down here, it says LCD move to 0, 1. So 0, let me put this out here. First value, so it's essentially X and Y coordinates, right? So X and Y value. So the first value is going to be X and the second value is going to be the Y. So because I say move 0, 1, the X value doesn't move. So it doesn't move along like that. Because I say move 1, it goes from 0 at the top to 1 at the bottom. So if I had this at 0, 0, for example, that would be the very first line at the top. And this says the line at the bottom. I can also change the X value to move it along. So King Boss, I can move that along maybe 3. So I'm going to say lcd.move to 3, 1. It should still be on the second line, but there should be some space before the King Boss. So I'm going to press F5 now. 3, 1. As you can see, yeah, it's moved in 3 places to the right. Let's bring that up. That's why we have a gap there. Those 3 boxes at the beginning, I've told them to be empty because I only wanted to start writing at 3 and 1. So I've gone back to that previous code again I found from Tom's Hardware or wherever I got it. And what I've done, I've said sleep for 1 second, clear the LCD, and blink the cursor. That's all that this is saying. So as you can see it running there, I'm going to press F5 again. The message is going to come up, stay there for roughly a second, then it goes away and the cursor starts blinking. So we have quite a few actions that we can do with the LCD. Let me close these files I don't need, and let me just keep putting a few things in. So we can blink the cursor, we can put string, we know how to do that. We can do LED cursor off so we can stop the blinking as well. So maybe copy that one in, and let's maybe sleep for 2 seconds. So sleep, let's put 2 seconds here, then we turn the blink off. So I'm going to press F5 here to run this one. Message gets displayed, 1 second, waits, blinks, and then 2 seconds later it goes off. So that's perfect. That's working fine. Let's go and try another thing. What else can we do? Let's do LED backlight on. Okay, fine. So let's go back to our program here. Let's sleep for another 2 seconds. Sleep 2. Now the reason I'm showing you guys is you can use all of this functionality to build up the functionality of your system. LED backlight on, and then sleep for another 2 seconds. And then let's do LED backlight. Let's do this one to off instead. OFF. I'm going to press F5 on my keyboard again to run this. Message comes up. Message goes away. Blinks for 2 seconds. That one there. And the backlight should go off at some point. There we go. Backlight off. So I've turned it off. So we actually can't see anything on the screen now. Now go to another one. Another thing that we can do is we can hide the cursor. Don't really want to do that. That's fine. Put string clear. I don't think there's anything else we need to really worry about. I think maybe these are the 4 or 5 main commands. So let me go over them again quickly. First one is to clear. We always want to clear the LCD before we do anything. That's important. And it's important so that we don't have things from the previous code we ran still on there. We want to put str means to put string. So if I had a value here, let's create a new value. Let's call this age. And if I do age equals 100. And if in here, if I put the variable 100, this should not work. I don't know if it will, but it shouldn't work, because what will happen is going to tell me that this is an integer and it requires a string. So let me press F5. There we go. It tells me it's not iterable because this needs to be a string. So the way I can convert it to a string again is str in front of it, open bracket, close bracket at the end. That should convert this to a string. So whatever is in here, it could be 100, 1 million, 1,000, whatever. I press F5 again, and that should be written to the screen. Yep, that's working perfectly fine. Now, the next thing we can move to a specific location that we want. Remember, we have 16 columns and 2 rows. The first value is the columns. The second value is the rows. So we have 16 columns and we have 2 rows. Keep that in mind. So we can say maybe 16,0 or 15,0, and that would be the first or second column. So play with these numbers to see which one works best for you. But in most cases, if you tell it to just start writing, we'll write from 00 down to the maximum. So I can actually do something like this. Let's put 32 things in here. So it writes across both lines. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. So this is a very long string, which is fine. But when I press F5 on my keyboard again, it does write all of that. But because I wrote the king bar stuff there as well, it kind of looked a bit weird. So let me remove the king bar stuff. Let me remove all of this stuff and write that same thing again. Stop running that. Let me press F5. Now, when I run that again, all that text should be on screen. It didn't stay on there for very long, but the fact is it worked. Next, I slept for 1 second. Then I cleared my LCD again, because remember, you want to clear your LCD before you do anything to it, before you write anything to it. I said blink the cursor, so the cursor was flashing on screen. And then I slept for another 2 seconds and I turned the cursor off. That's all this is saying. Now, this is one of the reasons why I really like Python for teaching people how to program or getting people introduced to programming, because the level of abstraction is really good. And that's a good thing and a bad thing. What the level of abstraction means, I don't know what this underlying code is supposed to do. But because Python's nature is to be very readable, I can figure this out just by understanding English. It says LCD, so I know this is something to do with the LCD. Now, we know what a cursor is. So if I say blink cursor off, it's most likely going to be blinking the cursor or turning it off, right? Then down here, I say sleep for 2 seconds, LCD backlight on. The backlight was kept on. And then here I slept for another 2 seconds and I say LCD backlight off. So I turned the backlight off. These are the 4 things I'm going to focus on when doing LCD. But to be fair, in the future, I'm simply going to put string to the LCD. I'm going to put values to the LCD. For example, the next video I think I'm going to work on is putting the LCD, having the temperature being written to the LCD in real time, and maybe having the LEDs work as well. But regardless, I'll maybe say temperature is, let's say 24 degrees, green LED on. Temperature is 10 degrees, red LED on, something simple like that, right? But that's how the LCD works. Hopefully that made sense. You need to save both of those files I told you about earlier, and those files again are I2C LCD, that one there, and LCD API. I will put these in the description. Simply download them, save them onto your Raspberry Pi as exactly the same names that you download them as, and you can start doing your LCD stuff like I did here. And that's it. So thanks for watching. Hopefully that was useful.